Okay, periodic trends, chapter 7, sections 6 through 8. Our first slide here is of the periodic table, and it is showing you that metallic character increases this way and increases down this way. You pretty much knew that it increased in this direction because the metals are found on this side of the periodic table, right? On this side of this stair step, and then the other side over here are the nonmetals. So the more it is to the left and down to the bottom, the more metallic it's going to be. Okay? All right, metals. They conduct heat, they conduct electricity, they're malleable. These are what we call metallic characters. Okay? And take a look at this little chart right here. If you look, helium, neon, argon, krypton, xenon. So those are that's one family. That's the family on the left side or right side of the periodic table. Here's lithium, sodium, potassium, rubidium, cesium. Okay, that's the family on the left side of the periodic table. These guys are metals. All right. Anything underneath this line is a metal, and it's showing you the ionization energy of those. Okay, look at the ionization energy of these little reds. The reds are metals. The blues are your nonmetals. So all of these metals have a low ionization energy. Why is that? Because they're willing and they want to get rid of that electron. So it doesn't take a ton of ionization energy to get rid of an electron. Up here, these guys don't want to get rid of their electrons, okay? So it takes a lot of energy in order to pull one away, all right? Okay, and then this is just showing you the different states, the different oxidation states. These guys we know, okay? These guys over here, we know for the most part when you're up in this area, okay? But it's showing you that the transition metals, we don't necessarily know what their oxidation states are. And you've got many of them that have two possibilities, okay? And this is actually a characteristic. The ability to have more than one oxidation state is actually a characteristic of the transition metals, all right? Okay, and then we need to state that metals plus nonmetals equal an ionic substance, which you guys should already know. Positive plus negative ionic substance. Okay, metal oxides tend to be basic. Metal oxide plus water equals a metal hydroxide. You don't get much more basic than a hydroxide, all right? And metal oxides plus water equal a salt plus a base. This is another example, salt plus base, of the fact that metal oxides are basic, okay? Why? Because what do you get when you mix an acid and a base? You get salt and water. So in this case, this is our base. What must be our acid? This is our acid, okay? Nonmetals. Nonmetals are not lustrous. That means they're not shiny and pretty. They're poor conductors of heat. They're poor conductors of electricity. They have low melting points compared to the melting points of metals. A nonmetal plus a nonmetal is molecular. Or another way that we say this is it's going to covalently bond. Okay? It's a covalent bond, nonmetal plus a nonmetal. Nonmetal oxides are acidic. Okay, metal oxides were basic. Nonmetal oxides are acidic, and we've got some proof for that. Nonmetal oxide plus water gives you an acid. That's the first proof. Nonmetal oxide plus base